Hi everyone, and welcome to today's flipped instructional recording. Today we're going through the lesson, the Drop and Bounce Lab, which is your first teacher graded assignment. You want to be sure to take notes during this recording to add to your science notebook slide. I'll also be sharing data and going through the experiment, so you will want to write down some of that information as well. So as we look at the first part of the Drop and Bounce Lab, which is 1.10, you can see some instructions here that I've added. It says you'll be performing a virtual experiment in this lesson. Be sure to follow the steps exactly. You'll be doing a simulation from pages in the lesson. No lab materials are required for this experiment. You'll use the data you collect and your experience to complete and submit your lab report later in lesson 1.13. So as we take a look at the lesson content, sorry, I misclicked there. We get into the lesson introduction. My computer's moving a little slow today. So again, we're talking about bouncy balls and how bounce height is affected. We've talked about this a couple of times in this unit so far. So today it's asking us to attempt to find the answer to this question in this lab experiment. So how does the temperature of a bouncy ball affect its bounce height? This is an important thing to have written down because this is going to serve as the purpose of our experiment. That's our question that we're trying to answer. So from here, you'll be developing a hypothesis, which if you remember, you've probably learned that is an if-then statement. If the temperature of a bouncy ball is low or is below a certain temperature, or if the temperature of a bouncy ball is higher, it will bounce higher, or it will have a higher bounce height, or it may have a lower bounce height. So you're going to take a guess here. You don't know in your hypothesis. You're just taking in what you've observed so far, and you would be writing out your hypothesis statement. You may want to pause the recording and do that now, just because you will see that on your lab report coming up. But now that you're thinking of it, you may want to pause and write that hypothesis now. So here are our lesson goals. We've got a couple of things going on and some keywords that you are definitely going to want written down in your notes. So we're going to be identifying the variables, independent and dependent, the tools that we've needed to gather and data. You're going to describe how our measurements will be recorded. We'll conduct the investigation. You're going to use the data as a basis for evidence to answer questions, develop a hypothesis, analyze displays of data to identify linear and non-linear relationships, consider limitations of data analysis, identify a pattern using graphs and charts, and describe the properties of different types of materials. So the key words you need to remember are controlled variable, which is a factor that will not change during the experiment. You've also heard of that referred to as a constant. The dependent variable, and you may want to make a note on this. So in an experiment, this is the variable that the experimenter observes as a result of changing the independent variable. And we'll talk a little more about that coming up. The independent variable is the variable that the experimenter changes. So we'll talk more about these in our experiment coming up. The other thing that you want to be aware of on the next slide, one, it does have guiding questions here, so these need to go on the right side of your slide. You're identifying your independent variable. This is the thing that we are changing in the experiment. If you think back to the question, the purpose of the lab while ago, was the temperature. Does the temperature of the bouncy ball affect the bounce height? So the thing that we're going to be changing is our independent variable. And in this case, it is the temperature. The dependent variable, it's the thing that depends on what we're changing. So in this case, that's going to be the bounce height. It's usually something that you measure. So a dependent variable is usually something that you're measuring. And in this case, it's going to be the bounce height. What should you keep constant? So if we think about going through an experiment and we are going to heat up or cool down a bouncy ball, we are going to want to keep the ball that we use the same. We're going to want to keep the height that we drop the ball from the same. And what tools are we going to need to conduct this experiment? We're going to need a ruler if we're measuring height. We're going to need some way to heat up and some way to cool down the bouncy ball. And we are going to need a bouncy ball. All right, so hopefully you have those answers on your slide. And we're ready to get into the simulation. All right, so here it is showing us just a picture getting started. And in this experiment, you will use a simulation. That means we're watching almost like a video or a cartoon image of this happening, and we're getting our data from that. And so if you had your own bouncy balls and your own materials, you could do this on your own at your own house. But most of us do not readily have those available. So you're just watching the simulation coming up in the next few screens. And we're going to make measurements using tools in a simulation and make a claim about the relationship between the temperature and the bounce height. So how do those things maybe work together or cause a difference? All right, so you've got a couple of things going on over here. One, this is your lab report paper. This is what you're actually typing on and submitting, so you need to save that file. This is the rubric telling you how your lab is going to be graded. And this is the lab guidelines, which gives you specific information about the steps you need to follow to complete the experiment. And I've had many students not open this, or they opened it and they looked through the first few things and thought, you know, I don't really need to know this information. So we're going to take a look at it together really quickly because you do need this information. So this talks about the simulation that we're providing. So this is a virtual option. Gives you a little bit of information about lab safety. So if you're watching a screen, obviously you don't need to worry about having a ventilated area and things like that. So I think this is where a lot of students, they kind of looked through this and they stopped reading, right? So after they got through the lab protocol and they knew they weren't using chemicals, this is just your basic lab safety. But as you scroll down, it talks about some things that are important. Taking good measurements, calibrating a scale. We're not using a spring scale in this experiment, but it does talk about using a data table to record your data. And a lot of students did not submit their assignment with a data table. So that's required. You also, it's asking you to plot your independent and dependent variables on a graph. So that needs to be included on your submission. And so it tells you where the independent variable goes on the x-axis, and the bounce height is the dependent variable, goes on your y-axis. So it tells you exactly how to set it up, and then it shows you how to draw the lines, shows you what is correct, what is not correct, all of those things. So this is going to be a document that you may want to look back on. All right, so if we get back to the lab, we're now going through the question you're seeking to answer. How does the temperature of a ball affect its bounce height? So again, that's the purpose of our experiment. As you work through the investigation, you should gather evidence to support your claim that answers the question. So when we look at this, what do we know? How do we know it? And why does your evidence support your claim? All right, so how does the temperature of a bouncy ball affect its bounce height? You will attempt to find the answer to this question in this lab experiment. Before beginning, formulate a hypothesis and compare yours to those of other students. So we aren't doing discussions, but you can compare them to student A and student B. So you do need to formulate your hypothesis. Remember, that should be an if-then statement. So if the temperature of the bouncy ball is blank, then the bounce height will be blank. So that is a very good hypothesis statement. You need to fill in what you think will happen. Okay, so watching this little 14-second simulation, it's just showing bouncy balls bouncing everywhere. There's really no information here for us, but student A says, if the temperature of the ball affects the bounce height, then the ball will bounce higher when warm. Student B says, if the temperature of the ball affects the bounce height, then the ball will bounce higher when cold. So compare yours to that statement. All right, so we're identifying the variables. In this experiment, you're going to look at the bounce height of a bouncy ball at several different temperatures. Consider the following to plan your investigation. What is your independent variable? Okay, we know that it is the temperature of the ball. What is your dependent variable? We've talked about that. We know that it is the bounce height after releasing the ball. What should we keep constant? We know that the height from which the ball is released and the type of ball we use should be kept constant. And what tools do we need to conduct our experiment? We need a meter stick or a metric ruler. So if you're talking about scientific tools, that's things like, do we need a beaker, a flask, a scale? In this case, we need a meter stick. So we did talk earlier about we need a bouncy ball, we need something to heat it, something to cool it. But the most basic answer, the scientific tool we need is a meter stick or something to measure with. Oh, I think I need to go back. All right, so construct a data table. Before conducting the experiment, you need to set up a data table to record your results. And in doing that, you know that every experiment needs to have at least 3 trials of each variable to compare to. And then you usually take an average. So using the simulation to conduct the first part of your drop and bounce investigation, before testing the effect of the temperature on the bounce height of the ball, we need to conduct a control test to make sure all of the balls bounce the same. Right now, all the balls are the same temperature and are identical except for the stripes. Raise each ball to 70 centimeters and test to see that they reach the same bounce height on their first bounce. Then proceed to the next part of the experiment. So this is the first data table information you will fill in. So you'll have, remember on a data table, you're going to have like ball 1, 2, 3, and then you're going to have trial 1, 2, 3. So you want to make sure that you're getting information collected. We have 3 different balls. We're going to need to record the same temperature. So this is going to be room temperature. That's about 70 degrees Fahrenheit. So you would have ball 1, Start height or drop height, it's going to be 70 centimeters. Temperature, you could put room temperature or you could put 70 degrees Fahrenheit. And then you're going to record the bounce height. So here's ball 1. We want to make sure that the bottom of the ball is at the 70 every time. And this is kind of tricky to tell when you drop it where it bounces to. You have to kind of look pretty quickly. So it looks like maybe 40. And you could do this one 3 times to see. I'll let go of it. It's kind of hard to do on my laptop. So hold it up here. So it's about 40. Ball 2. Well, it's going to need to move this ball out of the way. That could affect it. Okay, we're holding it up. Okay, it looks like it does about the same. And then ball 3.
So as we look at the next part of the investigation, we're looking at the ball with one stripe was placed in a freezer overnight so that it reached a temperature of 0 degrees Celsius. So on that data table you're using, the ball with one stripe is 40 degrees Celsius. You'll want to put that temperature down. The ball with 2 stripes was placed in an oven at a temperature of 40 degrees Celsius. And the ball without a stripe was left in a room of a temperature at 20 degrees Celsius overnight. Okay, so you have 0, 40, and 20 degrees. We're still raising each one 70 centimeters and recording the bounce height. Remember, you want to at least do this 3 times for each one and then find an average from your data. So your data table will need to do so the ball with one stripe, you'll need to have 0 degrees. You'll need to have a starting height of 70. Again, it's hard to pick up with my mouth. And a bounce height, and you'll need to do it 3 times. Okay, then you get the ball without a stripe. It's basically left in a room temperature. So we should see it doing something similar, 40, like we saw before. And then we have the one that is warmer. And you can see just from that it bounces much higher. You have to just have the other balls out of the way. So now we're having kind of a crazy, silly ball bouncing contest here. So starting at 70, so you can see it's bouncing much higher. And you'll need to record data for all 3 different balls and the 3 trials for each one. And then it'll ask you to get an average. All right, so let's get to the lesson review. It actually just put us in another lesson, so let's go back. That's at 1.11. I'm not sure how that happened, so let's scroll back down and get back into our 1.10. All right, so just checking here to make sure we got through all the parts of the experiment. We did that. We did all 6 pages of that. It's not letting me, sorry, I have to go through each one again. My apologies. Okay, so that was our experiment part, and then we're going into the lesson review. Nope, it keeps taking us to that. So we must be finished with all the pieces of the experiment there. So the next thing I want to look at with you really quickly is just what it's asking you to do in the lab report. So when you go through 1.11, it tells you how to analyze your results. It also works with you on making a graph and maybe even looking through your data table to make sure that's correct. So to complete the lab and submit the lab, that's actually done in 1.13. And there's only a couple of slides here. So 1.13 does not really even have guiding questions. So the intro here is just reminding you, you've seen this slide, this was the intro slide of the experiment. And then it reminds you of the goals and your template there. It has the same control, dependent, and independent variable. And then remember, you probably, you don't need a science notebook template. You won't need a slide for this lesson because there's nothing in it except for those two pages there, and then this last page here where you have, remember those lab guidelines and just make sure you have everything included, and then complete that lab report and submit it to your teacher. So what we need to look at is the lesson page. So let me get back to it. So if you didn't print it out before, you can always find it in the Dropbox. So if we go back, I went back a little bit too far. If you go back into 1.13, if you go into the assessment, that's where you submit. So your page looks a little bit different from mine. This is where you're able to upload though your file for grading. So you'll always have the link to access that page again. So if we take a quick look at it together, we've talked through, you'll need to enable editing on your page so you can type on it. And then this is where you want to make sure that you have everything answered. So I'm just going to talk through these really quickly, and then you will be ready to fill it in and submit it on your own. So notice how it says to title it your file when you submit it in the Dropbox. And then we know the purpose of the experiment. We talked about that. The variables, so you're going to list out what those were. Your hypothesis, remember we wrote that, so it should be in your notes. The tools that we are using, so remember we talked about that. And I've had a lot of students here not realize when you're describing the procedure that you followed, it does need to be, you could do it in steps like 1, 2, 3, 4, 5. That might be easier. It's kind of like the steps of a recipe. You want to be very clear on everything you did. So I have students say, dropped a ball, recorded the data, and that was all they wrote. It needs to be a little more detailed than that. Talk about your controlled, drop the ball 3 times, recorded, from, and you even want to include drop the ball from 70 centimeters and recorded the bounce height. Then I tested the independent variables, so you could write that out in steps, in numbered steps, however, but you want to be able that somebody could read that procedure and follow pretty much the exact steps of your experiment. So number 2 is going to be a little bit longer of an answer. Recording your observations, you don't even have to put a sentence here, just enter. And if you want to print this out and draw your data table in, or if you want to enter a data table, you can put in a chart or table. It'll allow you to do that in Word. You can insert your graph, all of that will go there. And then your conclusion, there's a couple questions here. Your conclusion needs to be about 3 to 5 sentences. It's going to basically say, or is your hypothesis correct or not? What could you draw? So basically, my hypothesis was this, my data supported it or it did not support it. And then you're going to talk about, is there a direct or inverse relationship? So the temperature of the ball and the bounce height. Is there a direct relationship with those? Yes. Do we notice that the bounce height affected it? Yes. So there's a direct relationship. And then when you write an evidence-based claim, that's where you're going to put your data in. When the ball was 40 degrees, it bounced this high versus when the ball was 0 degrees, it had no bounce. Something like that. And then errors, sources of error in your experiment. So thinking about, remember things that kind of got in the way or messed up our experiment, even the simulation. So remember when I had the ball in the way, and if the ball bounced it and bounced off of it, that would affect the outcome. Or just being able to grab it and hang on to it with the mouse, or the exact preciseness of the ball being dropped, was it exactly 70 centimeters? So those are things that could cause an error. So what could you do to improve the accuracy and precision of your measurements? All right, so with that, you will upload your document here for grading. Make sure your graph and data table are included. So if you have any questions, please let me know. You can reach out. And then there will be a flip follow-up specifically for this coming. So if you don't see that, you could check out the recording for it, or attend any help lab that you may need for extra support.